Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in the topic ANOVA, here in this video we are going to see a method called randomized block design. So this randomized block design is also known as a two-way analysis method. So this is like an improvement to a CRD method, that is completely randomized design, which we have seen in the previous video. So we are going to introduce a concept called blocking to variability in this method. So here is a recall of the previous method, that is one way analysis. So in a completely randomized design we assumed the all units are homogeneous, but in real life this is rarely true because all the data cannot be homogeneous. So for example, in soil fertility it will be varying. Next, in student ability to understand the concepts will also vary. So this variation increases experimental errors. So the next is an empathy. So how to empathize with using a RBD method. So here we are going to let us consider a farmer field. So some areas are fertile and some areas will be less fertile. So if we apply the same fertilizers all over the land, it won't give a result. So the farmer needs fair comparison and reduced variability. In some parts the manure can be used in less quantity, whereas in some areas it should be used in a higher quantity or in higher concentration. It varies depending on the fertility of the soil. So it should be understand first. For example, it will be purely on the user needs and actively listen to the perceptions and foster user connections. Next is a defined part. So we define variation due to external factor, nuisance factors. Next is the need to control this variation. So the goal is to reduce experimental error and to improve the precision. Precision is nothing but the accuracy. So first is we have to understand the randomness. Next, treatment follow up, and the another side control follow up, and which in turn will find the result for this. Next is an ideate part in which we divide the fields into blocks. Next, each block is homogeneous. Next, we apply the treatment within each block. Next, we randomize inside each block. So the first is selecting blocking variations. So focusing on statistical consideration for blocking strategies. Next, we identify the problem statement. Next, defining the treatments and how might we question. Next is a prototype in which we have in the source of variation we have columns. Next, errors. This columns are nothing but the treatments. Next, row treatments are nothing but the blocks which we have created. Next is the error. So the sum of the squares of columns will be represented as SSE, and for rows it will be represented by SSR, and for errors it will be represented by SSE. So the degrees of freedoms will be the corresponding how many number of columns minus 1 and number of rows minus 1, and for the errors it will be R minus 1 into C minus 1. Next, for the mean sum of the squares it will be MSE, which is the ratio of SSE divided by degrees of freedom. Similarly for rows and errors, so the F ratio is nothing but comparing or is the ratio of mean sum of the squares of rows columns with errors. So which we have know that already that F ratio will be always greater than 1, so that F ratio should be suitably adjusted. So here is the practical applications of randomized block design. This is again, it is used in agricultural, in case of soil variations. Next, in education, so the student groups the ability to study. Next, in manufacturing, the badge variations, so because all the badges cannot have the same accuracy. So the next is advantages. So this reduces error significantly, so this is more precise than completely randomized design. So here is the mind map in which we have studied the core principle and how to apply these advantages, disadvantages and applications. So this is in RBD the experimental units are grouped into blocks. Next, the purpose of blocking is to reduce experimental error. Next, RBD is analyzed using two-way method. So here are the references, and thank you. Let us see Latin square in the next video.